Under motion, you need to also remember that average speed is going to be total distance moved divided by time taken. So if you are given a question and you are asked to state the formula connecting average speed, distance moved, and time taken, this is actually the formula they will be asking you to state. So you'll be seeing questions that are asking state the formula that connects given quantities. Basically, in that the examiner is testing you whether you remember the different formulas that you are introduced to in physics. So we need also to look another formula that you must remember. Another formula that you have to remember is the formula that connects force, mass, and acceleration. So we are going to say force is equals to mass times acceleration, which is force is equals to ma. So this formula is very, very profound in physics. There's no life without this formula. There's no life in the physics world without this particular formula that we have stated here. Force equals to mass times acceleration. So don't forget to also look at the formula that connects velocity or speed of a wave, frequency, and the wavelength. That is now when we shall be talking about from the topic of electromagnetic spectrum. You learned the formula for that connect the wave equation. That is to say, the wave equation is wave speed is equals to frequency times wavelength. So this one also you will not be provided. You have to know, you have to remember this formula because you may be expected to use it. Don't forget that frequency also is 1 over t, meaning frequency of a wave is 1 over the period of the wave. These are the formula from waves. This is motion, and also this is motion. And then we have this one for pressure, and this from pressure, and this one is also from pressure. And this is a density of materials. We have already mentioned how to use also that particular formula. Don't forget the formula from work done. Work done. Remember, work is force times distance. So that is also another formula that you really ought to remember before you sit for that exam. Still, we under work power and yeah. So work done, we have already mentioned that. Work done, we have mentioned that. So this is the formula for work done. You need to check which other formula do you really need to remember. We need also to mention the formula for efficiency of machines is useful energy output or power output or energy output over total energy output times 100. So times 100, which is actually equal to this is now when you expressing it in percentages. When you're expressing it in percentages. So this is going to be gravitational potential energy formula. You will not be provided that. You must know that gravitational potential energy is mass times gravity times height, mgh, and this represents the mass, this represents gravity, and this is the height. So something that you need using this formula is that the units must be in SI units. So this must be in kilograms, 10 Newton per kg, and this is should be in meters. So meaning that if the units are not in meters, be very sure to convert that so that you can be able to get all your marks. Another formula that under this area that you must know is the formula to calculate kinetic energy. So kinetic energy is possessed by objects which are in motion. So you need to remember that that is a half times mass times the speed or the velocity squared. So and whenever you are writing these formulas in your exam, make sure you write them in words. You write them in words first, and if you are going to use these initials or these symbols for that, they must be correct. So that's it. And we need also to move to current, electricity. Which are the formulas? Electricity, which are the formulas that you need for current, electricity? Question: one of the formula that you need for current, electricity questions is that this alpha and omega formula for current, electricity, which is V equals to IR, which is actually Ohm's law. And this brings us to a point whereby if you are having a graph of velocity against current, if you get a straight line, it means this object is obeying Ohm's law. So it's a straight line because current and voltage are directly proportional to each other. So this formula is very, very, very key because you can be able to rearrange it in different ways so that you can be able to work out different quantities here. Remember, from here we can say resistance is R equals to V over I in that given point. So remember, even this from the velocity, from the voltage current graph, you are going, if you work out the gradient, that's going to give you the resistance of a given material. Now, on that note, different graphs that we are going to have here. If you are talking of a graph of voltage against current for a bulb, you are going to have a graph that is like that, right? So all right, so another formula under current and electricity that you really need to know, or you must know, another formula for current electricity that you really need to know and must know is electrical energy equals to IVT, meaning current times voltage times time. This is another formula that is very, very important under current electricity. Don't forget that also formulas for power. Power equals to, under electricity, power is equal to current. Power equals to IV. Power is actually IV in electricity, but power under work done. Power under work done. Power under work done is work over time taken. Power is work done over time taken. It's the rate of doing work. And also this formula can be given as power equals to energy over time, the rate of transferring energy. So you need to differentiate power in electricity and also power when we are talking about work done, and also energy transferred, or energy, yes, the rate of energy transferred. So these are key formulas that you need to remember. Also, don't forget that energy equals to QV, right? QV. Don't forget that formula. Don't forget that charge equals to current times time. Charge transferred, electrical charge transferred, is actually equal to current times time. So these are the most important formulas that you have to memorize before that exam, because you may be expected to state them. So I've already mentioned that you are supposed to state the formula connecting, then they tell you the quantity they want the formula to be all about. So as I'm about to finish, I need also another last formula that you'll be asked, and that is formula to do with refractive index. So we know that refractive index is equals to sine of the angle of incidence divided by the sine of the angle of refraction. So that one also is very important because you must know that when a wave is moving from one optical medium to another, for instance, this is air and this is glass, then the wave is going to slow down, then it will bend towards the normal. So the angle we have at this point is called the angle of incidence, and the angle that we have at this point is called the angle of refraction. So if you are given a question from this one, they may provide you with this angle. Now suppose they tell you that this angle here is maybe 26 degrees, but this angle down here is not given. Then you are supposed to use an instrument known as a protractor. You are supposed to use a protractor in order to measure the angle of refraction. So meaning that for you to measure that angle of refraction, you are measuring the angle from the normal. So you have to determine this angle that we have at this given point. You are going to measure this angle that we have here. So while measuring that angle, you place your protractor properly. Let me extend this a little bit. You position your protractor properly, and you can see now you are going to use the inner scale. The inner scale, now this angle is going to be around 20 degrees. If I can be able to check, this angle is actually 20 degrees. Don't use the outer scale, use the inner scale, because you start from 0, because the other one is starting 0 from there. So ensure you are using the correct scale when you are using your protractor. So meaning that before you go for that exam, you have to ensure that you have a ruler, you have a pencil, you have, for you to draw the graphs, pencil to draw the graph, you have a protractor in case a question from refraction and all another, you are supposed to measure angles. Then you are supposed to have all the apparatus. You have a ruler, you have a protractor, you have your, yes, what? You have your pencil. Ruler, pencil, protractor are the most important apparatus you need as you are proceeding for that particular exam. So the angle of refraction will be equivalent to, when I measured this, I got it 20 degrees. So meaning that if you are going to work out, if you are going to work out the refractive index is a ratio, so it doesn't have units. So you are going to say refractive index is sine 26 over sine 20. Then you are going to get your answer.